Hello, today we're going to talk about conditional statements. Now, a conditional statement is a way where we can execute certain Python statements conditionally, hence the name, based on a certain condition. So the term condition is going to pop up a lot, but what do we actually mean by a condition? What we actually mean by a condition is something called a Boolean condition. Now, in this case, we're trying to evaluate something as if it's true or if it's false. Now, the way we do that is we use one of these comparison operators that I have on your screen. So the first one is the double equal sign. So notice that a single equal sign is known as the assignment operator. That's how we create a variable or reassign a variable a certain value. But the double equal sign is comparison equals. That's if the left-hand side, in this case, A, is equal to B, that will be equal to true. So let's take a look at how that's going to work. So let's say 1 equals 1, B equals 2 equals 1 or something like that. And then we're going to print A and B. So what you're seeing here is this is a Boolean operator. And what it's doing is it's comparing 1 with 1 and seeing if they're strictly equal. That's what the double equal sign is telling you. So in this case, we're either going to get a true or false because once again, these are Boolean conditions. So whenever I run this, we get true for A, false for B. And the reason is because 1 is strictly equal to 1. B, where 2 is not equal to 1. And so that condition, where if we just sound it out in plain English, we can say, okay, is 2 equal to 1? That's false. Is 1 equal to 1? That's true. So that's how we're getting these values over here, true and false. So that is how we check if it's equal to each other. We can actually check to see if it's not equal by using the exclamation point and equals. So the exclamation point is what's known as the not operator. Now in Python, we can also use not, not. And in this case, what it's saying is this is not equal to each other. So let's take a look at what that's going to look like whenever we do that. So we have 1 not equal to 1, 2 not equal to 1. We run it, we get false and true. So in this case, we could read this by saying, is 1 not equal to 1? Well, that statement is false. In this case, line 3, it says, is 2 not equal to 1? In this case, the statement is true. So we get true and we get false. Now, this is going to be important whenever we combine these with what are known as if statements. But right now, we're just looking at the conditional statements. So these right now are the conditions, Boolean conditions that we're looking at. We have several more operators. We have the less than sign. So is A less than B? Less than or equal to sign. So that's less than equal to. Greater than equal to, not A. So there's the not. That's essentially the same thing as this, except it inverts all the condition. A is B. That is saying, okay, is this value that we've got here, or is this a list reference or something like that, equal to the list reference that we're referring to? Now, you won't use these a lot of the time. So these are generally not used as much as the other conditions. But remember in the last video when we talked about variables and types and things that like that, A, N, B, I, N. So in this case, we can create a list, have 1, 2, 3 in there, and then we can create. So remember, in is also a condition. Let's say 1 in A, and let's say C is equal to 5 in A. Okay, so now we're going to print A, B, and C. So A is the list. It contains 1, 2, and 3. 4 is asking Python to see if 1 is in A. So it's either a true statement or a false statement. So in this case, we can just look at it and see that 1 is in A. So B will be true. And then 5 is not in A. So that's going to be a false statement. So when we run this, we see 1, 2, 3, true and false. Now, remember, we can also invert this by saying, okay, is 5 not in A? Okay, so 5 is not in A. C is going to be, is that a true statement or is that a false statement? So in this case, 5 not in A. That's a true statement because 5 is not in A. So when we run this, we get true and true because 5 is not in A. And so it's telling us that that's true. So this not operator, you'll see it sometimes inside here or not, something like this, but it doesn't really matter. So not's going to invert the condition that it's within. So in this case, not 5 in A is essentially a weird way to say 5 not in A. So you can write it both ways and it will give you the exact same result. So essentially what we're looking for is this inside of this. Now, whenever it comes to something like a dictionary, we have to choose whether we're talking about the keys and values. Now, once again, in the variables and type selection, we saw one way where we can just narrow down the keys and one way where we can just narrow down the values. So taking a look at this, let's create a dictionary. Okay, and so now what we have to do is if we just have something like 1 and A, let's take a look at what that's going to give us. So notice it does not give us the syntax error, it gives us the value false. So let's see if we're actually looking at the keys or if we're looking at the values. So let's look at 12 in A. We also get false. However, we know the value 12 is in A. So maybe we're talking about keys. In this case, you can see, yes, indeed, if we don't put anything on the end of here, something in A, it's referring to the key. So in this case, B is equal to A in A. That's saying, does the key A exist in there? Now, this is kind of ambiguous if you don't know what's happening. So an easier way to do it is you can do something like this. Okay, so if you think back to the dictionary portion of the lecture that we had last time, in this case, we can narrow it down to just a list of keys or a list of values. So let's take a look at what this is going to give us. So what we're saying on line 4 is a part of the keys of the dictionary called A. And in line 5, we're saying, is 13 part of the values inside of this dictionary? And we can see just by looking at it, we can see that A is indeed a key because it's on the left-hand side of the colon, and 13 is indeed a value because it's on the right-hand side of a colon. So we run that and we get true and true. So this is what I'd recommend you do. A lot of people will just leave off the dot keys because that's assumed if you leave it off. However, it makes the code a little bit harder to read, as you can see, because if I just said for A in A or something like that, it's kind of ambiguous whether you're talking about, is that a key within A or is that a value within A? Remember, dictionaries contain both. So once again, I always recommend using dot keys and dot values, just so it's 100% clear to the reader who's reading your source code what is actually happening. So there we have it. Within, we have all the different Boolean operating conditions and things like that. So let's take a look at what is known as an if statement. So once again, Python, remember, starts at the top and starts running code as it hits it. However, sometimes we don't want to execute code based on a certain condition. So for example, let's say we'll have a simple username password system here. Now, if you know anything about Python, we can't put PASS because that's a keyword pass. So I'm going to put PASSWD. Okay. Now what we have to do is we have to make a series of conditional statements to see what we have. So the actual user we're going to say is smars, that's me, and the password is going to be John, something like that. Okay, so the only way we let the user into the system is if their username is smars and the password is John. So let's take a look at how we can actually execute this. We're going to use something called an if statement and those conditions that we saw, those double equal sign, the not equals, the less than, things like that. Now we're dealing with strings here, and we can compare strings differently than we can compare, say, integers and stuff like that, because what does less than mean? And we'll take a look at that. But right now we're going to use the strictly equal and not equal. So in this case, what we have to do is we have to make sure that the username first is smars. If it's not, we're going to complain to the user, say, hey, smars is not the user that you said. Okay, so I'm going to say if user is not. Okay, so remember, that's the same thing as saying if user not equal user. Okay, now I'd rather use line 9 because it's clear, but if you want to invert the condition, I just want to show you that not will actually invert the condition. So what we have here is we're going to print to the user, or print to the user that's using this. Okay, invalid username. Okay, so an if statement will conditionally execute the print based on whether user is not equal to the user. So in this case, we have what is known as an if, elif, E-L-I-F stands for else if, and then an else. So one or the other is going to execute in an if statement. So in an if statement, we have if and else if statements. So let's take a look at this real quickly. So we have an if statement, and then we have a line of execution that we're going to do there. And then we have the else statement over here and other lines of execution. Well, the thing about the if statement is if and else are mutually exclusive. So what this means is that we either run what's inside the if statement or we run what's inside the else statement. After the comparison is made, we are going to run one or the other, but not both. So else is the otherwise statement. So in this case, let's take a look at the Python code that we've written here and see if we can sound it out in plain English so we can actually understand what's happening. So in line 8, if we're saying if the user is equal to user, so in this case, smars, but then we invert the condition by saying not. If that's not the case, if user is equal to user and that's not the case, then we're going to print invalid username. Okay. The else is the otherwise to that statement. So otherwise, which means user is equal to the user, we're going to ask them to enter the password because now we know it is the user in there. And then we'll increase this in a little bit of complexity so that we can handle multiple users, multiple passwords, and things like that. So in this case, now what we're going to do is we're going to say, okay, now that we're on line 11, when we get here, that tells us that the username is SMARZ, SMARS. So in this case, we're going to ask for the password. So let's take this out and move it over here because we don't want to ask for the password unless we know that the username is correct. Okay, so now we have to execute another condition. So in this case, whenever they enter the password, we have to make sure the password is John. So what I'm going to say is if the user, well, in this case, we'll go the opposite direction. We'll say if the password is password. Okay, welcome. Now, how would we print the opposite direction? How would we say, okay, your username was correct, but your password was incorrect? Well, obviously that would be the else statement. So remember the if password equal password. If that is the case, we're going to print welcome. The else statement gets skipped unless the if statement evaluates to false. So in this case, we're going to say, okay. So hopefully you can follow the logic here. So let's follow the logic around and see if we can figure out what's actually happening. So right in this condition, the username is incorrect. Okay, so the username is incorrect whenever we get to this location right here. So everything else down here is not going to get executed because notice it belongs to that else statement. So nothing gets executed. It just prints invalid username and it quits the program. Okay. However, if I give the correct username, this statement is going to evaluate to false. And then we're going to move down here into the else statement. So now we start executing the next input where we ask for the password. So we're going to ask for the password, and then we're going to check to see whether the password is indeed the password that we want it to be. If it is the password that we want, we're going to print the value welcome. Now, once again, we have an else statement right here. So if the password is equal, the else statement gets completely skipped. And I'm going to run the program here in a little while, just so we can see and step through it to understand that this is exactly what's happening behind the scenes. So let's take a look at what happens whenever we run this program. So hopefully you can see how the logic is being developed around here. We want to ask the user for their name. If the username is correct, then we ask for the password. If the password is correct, we print welcome. If the password is not correct, we say it's incorrect. Okay, so now we're sitting over here and it's asking me for the username. So I'm going to enter the username John. Okay, so that's the password. It's not the username. So we should expect invalid username. And we get invalid username and it quits. Notice that nothing inside the else statement is executed. That's because these are mutually exclusive. If the if statement runs, the else statement does not run. If the if statement does not run, then the else statement does run. So let's run it again and give it the correct username, which is SMARZ. Okay, so now that we've hit this if statement evaluated to false, the entire thing, and now we're on line 10, where we're asking for input password. So I'm going to enter the wrong password. I'm going to say wrong. Okay, and then what's going to happen is this is going to evaluate to false. Why? Because wrong, which is what I entered, does not equal John. Because it does not equal, the comparison double equal sign will evaluate to false. So the if statement is false, and because the if statement is false, we execute the else statement. And so in the else statement, we say, hello, Smars, you entered an incorrect password, which is exactly what shows up on the screen. So now let's try it where we enter Smars, where we enter Smars and we enter John as the correct password. Okay, and we get welcome, which is right here. All right, so in this case, you can see how the logic flows. If Smars is correct, then we go into this else statement. If Smars is incorrect, we execute invalid username. Now you saw two different ways to do this. I could take the negative approach in the if statement, or I can take the positive approach, the affirmative approach in there. So in this case, we're saying if it's not the username, print invalid username. In this case, line 11 and 12, we're saying if it is the password, print the password, that sort of stuff. Sometimes based on how many statements are going to be underneath there, that's what will determine whether you want to choose the negative or the affirmative approach. So now what we want to do is we want to increase this so that we can actually support multiple users and passwords. So what would be the best way where we can support multiple users? Well, most of you would be thinking using a list. However, if we did that, we would have to do some sort of matching to find out what the password for each user is. However, we already have a data structure that allows us to match like that, which is called a dictionary. So I'm going to have a users dictionary. And what I'm going to do is I'm going to put a couple users in here. So Smars and John, that's the first. Oops, separated by a colon, not a comma. There we go. So Smars and John is the first username. John is the password. And the second one, we're going to say COSC, and the password is going to be fun. All right, so now we have two users and we have two passwords. So in this case, remember, we have key values. So we're using the key as the username. We're using the value as the password. And this should be fairly straightforward on how we're going to do this. So now what we're going to do is we want to see whether the username is inside of the dictionary, which we just did a few minutes ago, where we can say if user is not in users.keys. Now remember, if we don't add the .keys, it's just going to look at the keys anyway. So the .keys is a little bit redundant, but it makes it less ambiguous to the reader. Okay, so if the user is not Smars or COSC, in this case, it's going to print invalid username. Otherwise, we're going to come down here. Now what we have to do is we have to match the password right here. So remember, user, USER, is a variable that's going to store either Smars or COSC, because to get in this else statement, Smars or COSC or one of the keys inside of the user's dictionary must be available. Because if we look at line 5, if it's not in there, we're going to print invalid username. Because that evaluates to true, we skip the else statement and we're never going to execute down here. So now what I want to do is I want to get the value of that username, which is the password. So I'm going to do users, user. Okay. So remember, whenever we put the key inside the square brackets, it's going to return us the value. So in this case, we're saying, is the password equal to the user's password? So once again, if I type Smars, Smars is going to go into user. Now, whenever we do the square brackets on a dictionary by the key, it will actually return us the value. So in this case, John. So now it's asking, is the password equal to John? If it is, we say welcome. Now, one last thing we want to change is this right here. So Smars is no longer the user that we want. So we actually just want to print out the user. Okay. So hopefully that makes sense. We didn't really change anything around it. It is the same logic, except now we're allowing ourselves to support multiple users by using a dictionary. So let's take a look at how we're going to execute this code. So once again, we run it. We come down here. Let's enter wrong as the username. Okay, so invalid username is what we get. So this statement right here, if user not in users.keys, is going to evaluate to true. Why? Because as you can see, wrong is neither one of these keys. Therefore, it's going to evaluate to this right here. User in users.keys is going to evaluate to true, or I'm sorry, to false. And then this not is going to invert that into true. So remember, an if statement only executes the statements underneath it or tabbed over if the statement evaluates true. But since we have this not, it inverts that condition. User in users.keys is false because wrong is not a user. It's not a key inside this dictionary. However, because we use not, it's going to invert that condition into a true so that we execute these statements right here. Okay, so now let's execute it again. And let's type in COSC. Now we've passed this right here because COSC is a key inside of the dictionary. So it did not print me invalid username. And instead, now we're sitting here inside the else statement. So if we enter the password that we're supposed to enter is fun. But let's enter Smars' password, John, and see what happens. Okay, so now we get down to here. Why? Because remember, this user variable right here is COSC, which is going to return us the fun string. However, we entered John, so John does not equal fun. If that's the case, then remember this if statement evaluates to false We don't execute the statements under an if statement if it's false. Instead, we go to the else statement if one exists, and we execute whatever's inside there. Now, that's one thing, is not all if statements need an else statement. If you just want to conditionally run one instruction, there you go. You don't have to have an else statement. I see a lot of students write the else statement and then do nothing inside the else statement just because they think it's required to have an else statement. It's not. All right, so now let's finally do the last thing where we do COSC and fun. Okay, so COSC past this, and then we get down here, we do users, which is the dictionary, user, which is COSC, and that will give us the value fun, the password. So now we're comparing the password that they entered, which is fun, with the value fun. Those are equal to each other, so we get welcome. So that's how conditional statements are going to work in there. So we can have a list of conditional statements by using if, else, that sort of stuff. So let's take a look at using else if inside these statements. Okay. So what we're going to do is have this list here. Okay. So this list has 3 users. Now we could get this from a database or something like that, but right now I'm hard coding these in there just for an example purpose. Now what we can do is we can say if users okay, so if the value smars is in users, we print smars. If the value John is in users, we print the value John. Now, this isn't the best way. This is just an example. And then if Jacob is in users, we print Jacob. Now, as you can see, everything that's tabbed over. So because this if statement's not tabbed over under this one, it doesn't belong. We can actually chain these like this. So the only way we get to this statement is if John is inside the users. Okay. However, we can just put it on the back like this. So now all 3 of these if statements, no matter what happens in those conditions, whether they're true or false, are always going to execute. So we run this, we get smars, John, and Jacob. So let's do one last one where we do if Jenny okay, so notice we still get smars, John, Jacob. Jenny, it evaluated to false because Jenny is not in this list. And so because it was false, it didn't execute the statement. Notice that there's no else statement inside there. All right, so now let's take a look at the else if that I promised you. So this does not use any what's called mutual exclusive or exclusivity because smars can be in there, John can be in there, Jacob, Jenny. They're all equally likely to be inside this list. There's no mutual exclusive. Because smars is in the list, it does not exclude any other name from being in the list. However, let's take a look at well, let's see, income low equals 10,000. Okay. So in this case, we have 3 income brackets and we have 3 tax rates. So L stands for low, M stands for medium, H stands for high. And so what we're going to do is we're going to look at this tax rate to see, okay, are you a low income, high income, or medium income earner? We're going to add the tax rate. So this is not a progressive income tax. We're just saying if you meet this threshold, you pay 0.04%. If you meet this threshold, you pay 6%. And if you meet this threshold, you pay 30% on everything. So now we can see that we have a condition of mutual exclusivity. If I'm in the low income tax bracket, that means I cannot possibly be in the medium and high income tax brackets. If I'm in the medium, that means I cannot be in the low and high. So this is what's excluding other things. So if I'm in the middle, I'm excluding me being in the low and the high. So I cannot be in the high and middle simultaneously. This is the concept of mutual exclusivity. So in this case, what we're going to do is we're going to ask the income from the user. Okay, now it has to be a float, has to be some sort of decimal, because remember, input always gives us a string. So I'm going to convert that into a float by just saying float. Now you can put it here, but I want to parse it out. I want to have more statements just so it's clear to you what each step is doing. Now, I recommend you do that because if you get an error, it's all going to be on line 10. So if you have a whole bunch of things on one line, Python will complain to you and say, hey, line 10's got an error on it. And now you have to dissect everything. So when you're starting out, I would recommend just do things one step at a time. And then as you get more comfortable with it, then you can start combining functions and things like that. So we have enter your income. We convert it into a float. Now what we have to do is a series of if conditions to see which bracket they fall in. And then what we're going to do is we're going to charge them a tax rate. So right now the tax is equal to 0 because we're not charging them any tax at all. So the first thing we want to do is check to see whether they're in the high income, medium income, or low income. But remember, these are going to be mutually exclusive. So what we're going to do is we're going to start at the low income. This matters because if we start at the high income, it's going to change the way that these change. Because remember, we're always going to start at the first condition and move down to the last condition. So we can't get to the last condition until the first condition actually executes. So in this case, what I'm going to do is I'm going to say, if the income that you gave me is less than or equal to, so I had to take a little break there so that I can change my font so that it actually looks like it is. I didn't realize I was doing that, but now that we have the less than or equal to, this is the way that we do it. So now what we're going to say is if the income is less than or equal to the low income, then what we're going to do is we're going to tax the person the low tax. So we're going to take income and multiply it by tax L, and that becomes it. Now, if I did something like this, you can see I'm not using else. So there is no mutual exclusivity because this if statement is under 16 and it's not tabbed over, it's going to execute regardless of what line 14 gave me. So I'm going to do this and show you what should happen. So we're going to say you made, and then we're going to just print out the income and taxed. There we go. So as you can see, there is no mutual exclusivity. So this is wrong. So I want to show you what's going to happen when we enter something like, let's enter 1,000. Okay. So we're going to take 4% of 1,000 and we get 300. Okay. How does that make any sense? So what's happening here? So one of these things is, how do we get 300 in this? Because it should have been 4%, right? 40 bucks, that sort of stuff. Well, let's take a look at what's actually happening whenever we step through this. All right. So what's going to happen is we're going to enter our income. We're going to say 1,000. So let's take a look at what happens when we enter 1,000. So income is going to be 1,000 and income L is 10,000. This income, once again, is going to be 1,000. Income M is going to be 25,000. And this is 50,000 right here. And this is going to be 1,000. Now, remember, we didn't use any mutual exclusivity. So 1,000 is less than 10,000. Now, you and I both know, based on the sample of this problem, we should stop there, but we don't. Python goes on because there is no mutual exclusivity, and it's going to say, okay, is 1,000 less than 25,000? Yes, it is. So it sets the tax rate equal to the middle tax rate. And then line 18 executes because there's no mutual exclusivity, and it says, yes, 1,000 is less than 50,000, right? And so what we do is we take 30%, which 30% of 1,000 is 300. So to fix this, we need to add mutual exclusivity. That's your else statements. So what I'm going to show you is elif. Elif. Okay. So in this case, we have if, elif, which stands for else if. So that means if it's not the if statement. So one of these statements is going to, or none of these statements are going to execute. So we never get to any of the else statements if we have a previous true. So if the income, which is now 1,000, is less than income L, which is 10,000, that's true. We're going to set the tax rate equal to 4%. Now what's going to happen is because this says elif, else if, it's going to skip these statements because we got a previous true. Now, since we have chained else if statements here, if we have, let's say, $60,000, well, 60,000 is not less than or equal to the low income, which is 10,000. 60,000 is not less than or equal to 25,000. And so you can see how we're chaining the else statements. It's like, okay, if 60,000 is less than or equal to 10,000, do this. Otherwise, remember, that's your else. Otherwise, go to the next statement. Is 60,000 less than or equal to 25,000? No, it's not. Otherwise, go to line 18. Is 60,000 less than or equal to income high? Okay, so no, it's not. So our tax rate in this case is actually going to be 0. So let's take a look at what happens when we run this. Okay, we run it again. We say 1,000 and we get taxed 40. Okay, so 1,000 in this case is less than or equal to income low. 1,000 is less than or equal to 10,000. So we take this tax right here. Because this evaluated to true, we skip this else, and then we go right down to line 21. So as you can see, this is essentially what's going to happen. Okay, so let's run this. Okay, so we have income. Okay, so now what I'm doing is I'm stepping line by line. Okay, so now we're at the income. I'm going to step through it. It will ask me what my income is. Enter your income. So we enter the income. Let me put a break here. There we go. We're going to enter 1,000. Okay, now we're sitting at this breakpoint here. So income is 1,000. Is that less than or equal to income L? So let's go over to here. All right. So now what we're going to do is 1,000 is less than that. So we're going to step. Notice that we go into line 15. If this was not the case, we would skip line 15. We're going to step over that and notice it skips line 16, line 17, line 18, line 19, and goes directly to 21. And it prints, you made $1,000 and you'll be taxed $40. So that's 4% of 1,000. Okay. Now let's try this again using a middle tax rate. So let's say that we've made more than 10,000, but we've made less than or equal to 25,000. So the income that I'm going to put is 24,000. Okay. So notice we have 24,000, we pay 14. So let's run the debug. So what I'm going to do is I'm going to execute this. Our income is going to be 24,000. All right. So now that we're stopped here, we go to line 14. So 24,000, is that less than or equal to 10,000, which is income L? The answer is no. 24,000 is not less than or equal to 10,000. So remember what happens when an if statement evaluates to false. So that statement is false. So we're going to skip the statement, line 15, and then we run the otherwise conditions, the else. Okay. So notice right now we're sitting here. We're going to hit continue. Oh, that's not what I want to do. So I wanted to hit next. Okay. There we go. Okay. So let's step and notice that we're going to step over line 15. Okay. We stepped over line 15 and now we're in the else condition. So we have 24,000. Is that less than or equal to 25,000? The answer is yes, true. So we're going to step into line 17. As you can see here, we're now in line 17. So we step again and we're going to bypass the else statement because there is no otherwise here. And now we're at the print statement and it prints out this. So as you can see, this is how we get mutual exclusivity in there. So the else statement is what gives us an exclusive operation. Remember, we either have true or falses in here. And so we're using those true and falses to determine whether the condition that we're actually supplying Python less than or equal to in, not in, that sort of stuff is true or false. So if the if statement is false, then we consider the otherwise positions. If the else if statement, and notice we only consider positions after, conditions afterward, but we don't consider anything before. So it's not retroactive. We start at the top and we run down. So hopefully that makes sense on how the condition codes are going to work. So this double equal, not equal, less than or equal, things like that. And then the not, in, is, that sort of stuff. So let's move down into, let's see. How are we combining? So it's actually not in the lecture notes, but hey, I'll cover it anyway. So we could actually combine statements using and or. So let's take a look at this. Let's create a new program And in this case, we'll say, we'll go back to our user equals smars, password equals John, or something like that. Okay. Now, remember earlier we did this and we had an if, else, if that was for the username, or if and else for the username, and then an if and an else for the password. However, I could check both of them simultaneously using one condition, and we have to join it by either using and or. So let's take a look at this. So let's get our username. So we have the username, we have the password, and now what we're going to do is we're going to see if these are both, okay? So if user is equal to user, so you can see user is the variable we get from the input, capital user is the variable that I set above on line 2. If that's the case, then we know we've created. Now, do I want the username to be the username and the password to be the password, or do I want the username to be the username or the username or the password to be the password? Thing is and requires that both conditions or all the above, so we can actually combine them like this. This requires all conditions to be true for the entire thing to be true. So once again, this is going to evaluate to either a true or false. So let me show you this. We'll set it equal to a variable called a, and then I'll print a. Okay. So I'm going to enter username smars. Keep doing that. And then I'm going to enter the password John. So both of those are going to be true. So user equals user. So smars equals smars. That's true. And John equals John. That's true. So both of those are true. And we join it with an and statement. So think about an and. An and requires all of it to be true, right? So in this case, let's try it again, but we're going to do smars and Joe. Okay, notice it's false. Why? Even though smars was equal to smars here, the and requires all conditions to be true for the entire statement to be true. And you can see because this password statement is false, the entire statement becomes false. Now, if we put an or here, an or only requires one to be true. So in this case, if I type in jars instead of smars and Joe instead of John, both of those are false. That's the only way we can get a false condition. However, if we do smars and Joe, so smars is equal to smars, that's going to be true. However, this is going to be false. Now, remember, with an or statement, it's either this or both. Okay, so smars or Joe is now going to print out true. Why? Because this one is going to be true. It doesn't even need to check the right-hand side. So let's make them both true. And notice we still get true. So no matter what we do, the only way, if we join two statements with an or, the only way to get a false is if both statements are false. For an and, the only way to get a true is if both statements are true. So let's take a look at what is known as a truth table for an or. Okay, so we have statement A, B, and then our results. So this is false, 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 true, true, false, true, true. Okay, so A is right here, B is right here. So if username, which is A, is not equal to, so if that's false and B is false, then our result's going to be false, right? Because in an or statement, the only way to get a false is if both statements are false. Now, in this case, we have false for the username, true for the password. That's going to give us a true. True for this username, false for the password is a true. True for the password, true for the username, that's going to be a true. So that's for the or statement. Let's take a look at the and statement. So I'll draw this a little bit better, so it's not quite on a slope. And we're going to have A, B, result again. Okay, so this is and. If user is false and password is false, we're going to get false. If user is false and password is true, we're still going to get a false. If user is true and the password is false, we're still going to get a false. And if the password and user are both true, that's the only way we get a true from an and statement. So as you can see, we can actually join multiple conditions using ands or ors. So let me put this in an if statement. So now what you can see is line 8 will only execute, or line 9 will only execute if user is equal to user and password is equal to the password. That's the only way we're going to get those to execute. So let's take a look at what happens when we run this code. So I'm going to do smars and John, and notice we get welcome. Now I'm going to do smars, which is correct for the username, but Joe, which is incorrect for the password, and tells me invalid username or password. Now what I'm going to do is I'm going to do bars, which is incorrect for the username, but John, which is correct for the password, and it gives us invalid username or password. So the only way we get this welcome right here, because we joined it with an and, is for both conditions to be true. So let's recap what we've covered today. Number one, we took a look at these different conditions right here. So these operate are Boolean binary conditions. So they only take a left and a right. That's it. Are they equal to each other? Are they not equal? Are they less than, greater than, things like that. Now, one of the things that we have to look at when we do that sort of stuff is the data type. So if we have a string, it's actually going to check it in alphabetical order. So for example, ABC, this is indeed less than BCD. Why? Because in alphabetical order, A comes first. So we print A, it gives us true. Okay, let's try greater than. So is ABC further down the list in alphabetical order than BCD? No, it's not. So we get false. Okay, so let's do ABC, ABD. Okay, so notice that A, B are equal to each other, but this is going to be true. It's strictly less than because C. So it will keep going until it finds the first difference. Let's try equal to each other. That'll be false because they're not equal to each other. Let's try not equal, which is true. As you can see, strings are compared in alphabetical order, whereas integers are compared in integral order or numeric order. Remember, not is a way to invert a condition. Is checks the exact object. So if we have, this will be really like a list or something like that. If we set a list equal to something like that. For example, let's take a list L, 2, 3. Now, the weird thing about Python is if I set, let's say B equals L. So you would think this would create two different lists, but it actually B refers to the original list. So we can actually check to see if that's the case by saying B is L. Is B L? Yes, it is. So let's show you what's going to happen when we do that. So I'm going to print out the original list and the new list. But let's take a look. We'll do L.append 1, 2, 3, 4, 5. Okay, so what we would expect it to do if we didn't know any better is L would get 1, 2, sorry, let's do 4. There we go. So we expect that L would be 1, 2, 3, and 4, and B would be the original list 1, 2, 3. But look what happens. Notice both of them are going to get 1, 2, 3, 4. Why? Because a list, B is now referring to the same list as L is. Now, if we don't want that, there's a couple ways we can change that. We can do L.copy. Now you can see they're different like we'd expect. However, notice B is L now returns false. So that's the whole purpose of the is statement, to see, okay, are we referring to the same object? Yes or no? Because as you can see, if we are referring to the same object, what we do to one object changes the other because they're all referencing the centralized point there. So when we originally did it, our list was right here, 1, 2, 3, 4. It was referred to by both L and B. However, when we did L.copy, L referred to this, B got its own copy of the list, which was 1, 2, and 3. So that's what the is operator is going to tell you. Okay, are these referring to the same thing? Yes or no? If the answer is yes, we get a true. If the answer is no, we get a false. Okay, so remember in, that's the important thing. For lists, we just compare to see whether this value is inside there. If we did it to a dictionary, remember, if we don't add .keys to a dictionary, it will assume that it's .keys. But if we want to see if a certain value is in a dictionary, then we would do .values. So there you have it. Those are if statements and conditions. So as you can see, this is one way where we can actually check to see if a value, so we can error check, we can actually do the password protection like this, we can do the tax rate, that sort of stuff. So there's many things we could do with an if statement now that we can conditionally execute code. So there you have it. That's conditions for Python. Thanks for watching.